Welcome to the We Hack Purple stream. With me today is Shai Levy. He's from Noname Security, and he's going to give a demo on his API security product. And I'm really excited because I will finally know how to answer a lot of questions thanks to you, Shai.
Hey, good to be here.
Thank you for coming, and thank you to everyone who came to watch. Will you please tell us about APIs?
Sure. Why don't I try to share a few slides if that's fine? Yeah, let's
Yeah,
go.
absolutely.
All right. Um, Tell me that you see it. Yeah. Wait, still loading.
There we go, looking good.
All
Okay,
right.
I'm going to mute myself and let you take it away, but I will interrupt you at some point with questions. Let's just be honest.
Feel free. Feel free. All right. So, just in a word about myself and the company, so you know who am I. So, my name is Shai. I'm co-founder and CTO of Noname Security. Noname Security is an API security company, maniacally focused on APIs. Founded in 2020, raised $220 million to date. Over 250 employees, working with a lot of the Fortune 500 companies, and we're actually the worldwide largest API security company. Let's double click on API security and figure out what it means and why it's important to secure your APIs. So, first of all, why do we care about APIs? What changed? Because APIs existed for forever, but there's definitely a few changes that made us much more aware of the need to secure them. So we in Noname like to say that three major things happened with APIs over the last decade that made them as critical as they are. The first thing is that APIs are much more mission critical right now. That means that in any critical pipeline in the org, you'll have APIs involved, from large wire transfer to operating physical machines. If in the past APIs were just used for basic information or just to hand in configuration or things around that, now you almost won't find any critical pipeline that doesn't have APIs involved in it. We like to say in Noname that any piece of code that was written the last 7 years is either exposing or using an API. So that's the first thing. The second thing that happened is that the environment is very scattered. You have multiple cloud vendors, probably multiple cloud environments, multiple regions, multiple API gateways, multiple load balancers. And so this whole construct makes it very difficult to know where your APIs are. You actually feel it when you talk to large organizations that they're not quite sure where their APIs are. They know they have some on the gateway, they know they have some on a particular cloud, but that's about it. And they really need to know it better. That's why they come to us. The last thing that happened is that the dev velocity increased dramatically. Right now, you can probably create a new API in 2 to 5 minutes and deploy it. And it's constantly changing. And so it makes it very tricky for the security org to know what their APIs are doing or the org APIs are doing. And so if you're not really sure where it is and you're not really sure what it's doing, but it's involved in critical pipelines and is dealing with sensitive data, it's almost natural that it will become a very lucrative and a top attack vector. This is kind of what we saw in the market, right? Gartner kind of reiterated it, saying that in 2022, APIs would become the number one attack vector. And I believe by now we all feel it, right? There was roughly a month ago, there was a T-Mobile incident that was published. A month before that, there was the Twitter incident that 220 million user records went on the dark web up for sale through one vulnerable API, right? You don't need many. The impact is giant. And so every 2 to 3 weeks, we feel like another incident, another breach, another vulnerability is being found. We also ran shared research with S&P Global to kind of back it by the numbers. And API security incidents are way more common than you'd think. Large organizations seem to understand it, and they really want to secure their APIs. That's usually how it starts. They come to Noname and they're like, we know APIs are a major risk. What should we do to secure them? And so there's a lot of questions about what API security actually includes. And I think let's double click on that. So we at Noname created this model for what you need to do to secure your APIs. And this is what we'll go through today. Feel free to ask any question at any time, obviously. So we like to say that API security is comprised of three main pillars. The first one is what we like to call posture management, or if you want, discovery or inventory. The idea is to create an inventory for your APIs. Who owns those APIs? When were they last updated? When were they last seen? what type of sensitive data they're sending or receiving, and most importantly, are they configured properly? So if you have a misconfigured API, such as an internal API that's open to the internet, or APIs that should enforce authentication but aren't, or things around that, you want to be proactive around fixing it. You don't want to have to react to actual attack or actual incidents in real time. If you could fix those problems in, I don't know, 5 minutes, way before they're being abused. So that's the first pillar. The second pillar is what we like to call the runtime security or the runtime protection, which you hear a lot about if you look up for API security online. The idea is to analyze your API transactions as they are occurring, build a baseline for what is normal and abnormal behavior for an API, how a normal request looks like, how a normal response looks like, how they correlate, so on and so forth. And then if there's a deviation from the norm, you want to bring the attention of the security org. If there's an attack going on, you want to let them block the attacker and start the remediation cycle. And the last pillar is what we like to call API security testing or active testing. So right now, organizations are manually testing their APIs before they release them. Sometimes they don't test them at all. The problem is that it doesn't scale to the amount of APIs and to the amount of releases that they have. So what we want to do is let them automatically test their APIs for the OWASP top 10 API security issues and the OWASP top web issues as well, actually. And then give them confidence that whatever they are releasing won't introduce new vulnerabilities into their environment. So this is about instilling confidence in what you release. This is about fixing the misconfigurations proactively and fixing your environment and getting a good grip on your environment proactively. This is about protecting you. Yeah. Any questions before I proceed?
Sorry, someone came in and wasn't on mute, so I put them on mute. And
sure.
Everyone's on mute now. Sorry, Shai.
No problem. No problem. So in terms of how it works technically, right? Because I think that will help us wrap our head around this model. So Noname can be used as a SaaS and can be used on-prem. Like obviously we support either or. The main thing I want you to take from this slide is that the communication between the consumers of your APIs and the APIs themselves, that stays uninterrupted. You don't need to reroute your traffic through us. You don't need to install agents. We're an out-of-band solution. We're not influencing the natural flow of the transactions in any way. Rather, we rely on integrating with existing components that you already have in your environment. The cloud environments, the AWS, the Azure, the GCP, the API gateways, such as the Apigee or the Mule or the Kong or the Axway or the Akana, the load balancers, such as F5, that is very popular in data centers or nginx, containerized environments, such as Kubernetes or Istio if you're using Service Mesh. With any one of those integrations, we do two things. One is we configure them so we get a clone of the API transactions as they go through them. And two is we consume the configuration of these environments in order to see how these APIs are configured. That enables us to do posture management proactively because we see the traffic and the configuration. So even if there's no live attack going on, but you have a configuration gap, we can highlight it. And two, it enables us to do the runtime security because we analyze API transactions as they're occurring, build a model, ML, behavioral model, however you want to call it, for every single API. And then if there's a deviation from the norm, give you a chance to react to it, block it, start the remediation cycle. Now, before I go into the actual demo and kind of show you how it looks like, if you guys have any questions.
Does anyone have any questions? I know I just muted all of you, but now is your chance, or you can put something in the chat and we'll ask Shai later. I don't know, we have more and more people coming in, but they're all very quiet and polite. So
all right.
Good, Shai.
Okay, let's continue. All right, so once we integrate it, how does it actually look like? So just so we can wrap our head around this, if you go into Noname, there's no limit to the amount of integrations that you can add to kind of discover your APIs. We like to say that whatever you'll add in, regardless of where your APIs are, as long as they are on that component, we will find them and we will be able to add them to the inventory and monitor them in real time. So regardless if you add an Azure subscription, like we're very good in finding your APIs regardless of where they are on Azure and to monitor them. If you add the F5, like the load balancer that sits at the front of the data center, any API that is routed through it will be able to detect, regardless if someone marked it as an API or not, if you have it in your store, in your ServiceNow or not, like we will find it. You can even feed us with direct network feed, so off the Gigamon or even pickup files, and we automatically dissect it and find APIs regardless of where they are. So if you add a cloud subscription, if you add us to a centralized network point, if you add it to anywhere you want, we find those APIs and we monitor them and we track them. Any one of those integrations can take, I don't know, 2 minutes. Obviously, Noname is a software solution. There's no physical thing you need to deploy or anything like that. So once we integrate it, yeah.
Is Cloudflare on that list?
Yes, I believe so. This hasn't been seeded for a while, to be honest. So I'm not sure if on this demo, but yes, Cloudflare is definitely an integration that we support.
Perfect. We like Cloudflare. Thank you.
Sure. All right. So let's talk a bit about how does it actually look like, right? What does good API security look like? And this is heavily oriented towards security, but I actually want to start with the inventory piece because I believe good security starts with good inventory and good understanding of what you have. So in terms of the inventory, obviously the immediate question is how many APIs I have and what type of sensitive data those APIs are sending or receiving. But this goes as deep as the actual API spec. So if I go to my API inventory, obviously I have a list of all the APIs that Noname was able to detect. And if I click on a particular API, I see all the information about that API. Is it internet facing or not? Is it authenticated? Which environment it is on? Obviously, we automatically identify the authentication. You don't have to feed us with, hey, this is authenticated, this isn't. What's the API type? Is it REST, SOAP, GraphQL, gRPC, or XML? What type of sensitive data is it sending or receiving? And most importantly, the full API spec based on the live traffic. So this is not an estimation of what the spec is. This is not reliant on the developer documenting it. This is actually automatically built based on what's actually going on with that API. So you can use the specs that we build. You can download them and upload them to wherever you want or share them however you want. But you can also provide us with your own specs, and we automatically compare against them. So if you have all documentation or drift or anything like that, we let you know about that. If you marked a particular API as deprecated, but we still see it live in the traffic, we let you know about that, and so on and so forth. This gives you like a preview almost to how the anomaly detection is being done. Because if we are able to understand the API structure based on obviously the live transactions, and we're able to understand the different fields or where sensitive data is being sent or received, that's how we build a behavioral model. Like we understand, okay, these fields correlate, these fields, this is the normal ranges for them. These fields are always showing. These fields are optional. These are required. This one is an enum that's representing if it's an admin or a regular user, and so on and so on and so on. We build that behavioral model, and then we look for deviations where basically you have an attacker that is trying to abuse your API by, for example, the most stupid example of APIs is someone passing in -1 as the offset, and the whole DB is being dumped as a response to the API. Sounds silly, but it happens more often than you'd think. We also, from the configuration, able to understand where your APIs are on the network. So it's not just traffic-based, it's also configuration. So if we are able from the traffic to understand this API and what it contains and what it sends and receives, from the configuration, we can understand how it's routed, where it is in your environment, if it's routed to the internal network or the external network. And this also gives you a preview as to how do we do the posture management side. If we see an internal API that has an internet leg, for example, we can immediately highlight that too. We can take that inventory and slice and dice it any way we want, separate it according to the API type, separate it according to those that are internet facing or not internet facing. And then if I click on a particular group here, I'll immediately see the distinction and the list of APIs. I can also look at the inventory from the data asset side. So what are all the sensitive data types that the APIs are interacting with? And if I click on a particular sensitive data type, let's say social security number, I immediately get the list of APIs that interact with it. We also track API changes over time. Any change that your API's estate is going through or has gone through is automatically documented. If you click on a particular change, let's say a new API was added, I will get the API spec, like diff on the API spec right here. We'll talk about it more when we'll talk about security issues, but generally you can feed that information, like the changes feed or security issues that we find or anything like that, to any of the external tools the security team is already using, whether it's a Slack channel, whether it's a Splunk, whether it's a QRadar, whether a million Jira, ServiceNow, whatever it might be. And we'll see it when we'll talk about security incidents. Any questions that come to mind before I proceed?
There aren't any questions in the chat, but oh my gosh, this is really cool. General comment.
Thank you very much. All right, so let's look at this inventory and how we can slice and dice it a bit more. So obviously large organizations can have tens of thousands of APIs. So something that we enable them to do is to generate groups dedicated to business units or to a particular security need. So for example, if you want to create a group dedicated for your PCI APIs, you can easily create a filter on this table based on any of the parameters and then save that filter as a group. And this is what we have here. For example, the PCI group is already someone created that. The unauthenticated APIs group, and immediately a list of just those. You can also create groups based on a particular environment. So prod versus dev versus whatever it might be. So you can see here I have a group called workshop. If I click on it, I'll see all the workshop APIs and not just the entire inventory. You can also use that for role-based access control. So large organizations have, as I said, hundreds of thousands of APIs. Not every security personnel needs access to all of them. For example, the mobile security team needs access only to the mobile APIs. So you can create a group for the mobile APIs and give them access only to that one. So this is a bit about inventory. I know we went on it a bit fast, but again, feel free to ask questions at any time. Let's talk a bit about security. So the security side, as I said, the OWASP top 10 API security issues is somewhat of our compass. Obviously, it doesn't contain all, but a lot of these are broad categories. Like security misconfiguration is a broad category, right? There can be hundreds of issues that correlate to that. BOLA, or broken object level authorization, quite an important issue. We can go through each and every one of those, but the gist of how Noname looks into it is with our two security modules, the runtime and the posture. Runtime, as I said, building a baseline for your APIs, looking for deviations, bringing the attention to the alert. Posture, finding a misconfiguration or finding an issue before it's being abused and giving you a chance to react to it. So let's look at an example of a runtime issue to better wrap our head around that. So I'm going to look at a BOLA issue just because I think it's an interesting one. So this is a BOLA issue, broken object level authorization. With any one of our issues, we highlight what happened, why that's a problem, and what you should do about it. If it's associated with any of the OWASP top 10 issues, there would be a tag. Obviously, severity automatically determined. All the information about the API involved is right here. And as this is a runtime issue, there'll also be the attacker information because someone is actively abusing your APIs or trying to attack you. Then we give you all the information about this attacker. Now, what we do in runtime issues as an evidence, we give you the full recording, request and response that the attacker used against your APIs. We highlight the problematic packets in the session in red or the transactions in red. And the problematic part of the payload is also highlighted so you can easily investigate it. In this case, just so we understand what a BOLA issue is, the API is validating that the user is authenticated. So you won't be able to call that API unless you pass in a token. But the API is not validating that you're accessing your own info. Like you can access any user info just by putting the user ID right here. Now, obviously, this was not the intended behavior, like we understand it. But the way for the model to understand that is because we build a baseline, because we try to understand the relationship between a user and a resource, we kind of try to understand, is it a one-to-one relationship? Is it a one-to-many? And if many, how many? So in this case, this API was intended for a one-to-one relationship. A user was supposed to put in his own user ID / user details and pull out his own information. But smartly enough, by probably debugging, the adversary was able to find that API, tried to put in different user IDs here, and was able to pull out their information. So we can see that finding these issues manually is almost impossible. But with anomaly detection, it's actually quite feasible because obviously for a normal user, the relationship is going to appear like one-to-one. So 99.9% of the traffic is going to show us this one-to-one relationship. whereas the adversary is going to be 1 to thousands or 1 to millions if it takes you long to react to it. And so even if the relationship was like 1 to 5, the adversary would create a relationship of 1 to a million because they're trying to pull out the entire database. And then obviously the anomaly detection would flag them and give you a chance to react to it. When I say react to it, we enable you to block the adversary. This is an interesting part of the platform because we're an out-of-band solution, but we're still able to give you the blocking capability. The way we do that is by integrating with existing components that you already have in line. That can be, go ahead, Tom.
Sorry to interrupt, but before you switch topics, so are there different confidence levels for different types of categories? So you know how some products will give you false positives sometimes, and so you can say, like, are you extremely confident of this result or sort of confident, and are all vulnerabilities confirmed? So does that mean like, hey, can I just automatically open Jira tickets, or should I be a bit more cautious?
Right. Great question. So actually confidence levels is something that we've added. This demo, again, hasn't been seeded for a while, but in the actual latest version, we do have confidence level that you are able to use in order to decide if what action you take. We'll talk about automated workflows, which is what you refer to. Like, can I automatically just block it if I want without just manually clicking around? I'll also show you how we do that. But great point on confidence. Yeah, it's definitely something important that we've added. We do automatically determine the severity, obviously, but we also added like confidence level of how certain we are that this is an issue. Now, just as a general, because we're dealing with APIs and they're structured, we benefit from it greatly. So behavioral models that work on structured data work way better than if you would look for anomalies in emails or anything like that. Because if you think about that, a certain field is representing a resource, it's going to look like that for all the users that are consuming it. If a certain field is a credit card, it's going to look like a credit card or be a credit card for all the users that are consuming it. So the fingerprint of a particular field or correlation or anything like that is way stronger because it's structured. So we do benefit from it. Therefore, false positives are rare, but they're possible. Any ML product will have false positives in some ratio.
Sounds very good. Thank you.
Sure. So on the adversary, as I mentioned earlier, we can take preventive actions. Again, we're not out of band. The way we do prevention is by integrating with existing components that you already have, such as your cloud firewall. In this case, it's an AWS example. So it will use the AWS firewall. If I actually mark it here and press save, the adversary would be blocked. The blocking is done based on the best identifier possible. So if the API is authenticated, we will try to find the user identifier within the token or within the payload or anything like that, and block based on that. If the API is unauthenticated, we would fall back to IP, user agent, combination of the both. But obviously, we can't use a token because the API is unauthenticated. We can do blocking through the API gateways that you're using. So Mule, Apigee, Kong, whatever it might be, through WAFs you're using. So Akamai WAF, F5 WAF, whatever it might be, Cloudflare. We could do prevention through cloud components, so the cloud firewall, the cloud WAF, so on and so forth. So as long as you have something that can do the blocking inline, we'll use that. If you have nothing, you can still deploy an inline component of Noname and do the prevention through it. But in most organizations, there's already something in line through which we can do the prevention. We talked earlier about what we can do with issues. So yeah, we can block, but other than that, we can send it to Slack, we can open a ticket on Jira, we can send it to Splunk for the SecOps team. Now, most organizations won't like to do it manually or do it manually too many times. So as Tanya, as you mentioned, most organizations are interested in creating automated workflows, which is what we enable them to do. I'll click on create workflow. I can choose, which issues I want to involve in my workflow. So for the sake of the example, I choose high severity issues of the runtime module. And for these, I will want to automatically block and I'll want to send an alert to Slack. And then if I'll give it a name and a description and I'll press save, it will happen automatically. In terms of the outgoing integrations that we support, obviously quite an extensive list, but show it for a sec. the Slack and the Jira and the ServiceNow and any syslog integration or any webhook or the Splunk or the CloudWatch and the email and so on and so forth. Any one of these integrations can be involved in a workflow. The information can be sent automatically. The trigger can happen automatically. You don't have to manually come in and press buttons in order to make it work. So your team doesn't need to look at another dashboard, right? Generally, it will flow to wherever they're anyway looking, and then they can react to the threats.
Can the confidence level be part of the workflow? Is that possible?
Yeah. Yeah.
Awesome.
Yeah, obviously, because for example, you'll want to block only when the confidence level is high, right? That's a great example of a use case, right?
Perfect. Thank you.
Sure. Let's look at an example of a posture issue. I think that will also be interesting for us. So this one, why not? This is an example of a posture issue. As this is a posture issue, there's no runtime information involved because there's no session that someone is abusing it. There's no attacker. In this scenario, this is an Azure example. So this, just to double click on it, you have backend services on your Azure. They're routed through the APIM or the API Management Service of Azure. The APIM is configured with all the right policies. It's doing a rate limiting and it's verifying the authentication and a million of other things. The problem is those backend services also have a public ID of their own. So someone forgot to take that down. And so you can call the backend service directly, bypassing all the controls you have on the gateway if you just call it directly. So what do we do with these types of issues? Again, we tell you what happened, why that's a problem, and what you should do about it. But also in the evidence, we give you a direct link to the actual resource. So what this enables you to do, like if I click on this, fixing the problem will take me what? 2 minutes, right? Because I know which resource it is. I have direct link to it. And it doesn't have to be an Azure example. It can be Azure or F5 or Mule, depending on what I integrated with. But the idea is that with the 5 minutes work, I significantly de-risked my environment from ever needing to react to things in real time, ever needing to deal with a live incident. And that's why there's a great benefit to the posture side of things and not just the runtime. You reduce the attack surface, beneficial for everyone. And this is why we like to say that, if you try out Noname, you'll already benefit significantly because, you'll clean your environment of actual things that could have put you at risk in the future. Again, with any one of our issues, you can take action, which is sending it to Splunk or Jira or any one of those. Again, you can create an automated workflow. You can comment on any one of those. And that's about it on the posture side. Any questions on the runtime or the posture before we talk about our last pillar, which is the testing side?
So far, there's no questions in the chat. I'm finding this really fascinating. Are your slides available on the internet so we could link them when we share?
They aren't, but we can take care of it. That's fun.
I just have a feeling that people will watch this and be like, I want to, you know what I mean?
Sure.
It's really good. Thank you, Shai. Please continue.
Sure. All right. Let's talk a bit about the active testing piece. So active testing platform is separate, but it's very related to the other parts. So in the active testing piece, obviously, you can upload APIs from what we analyzed in the real time. So as I mentioned earlier, we automatically build specs, so you can use those for testing, but it doesn't have to be. It can be non-live APIs that you work on locally that you have the specs of, or a Postman collection of an API you want to test, or some curl commands in a text file, or an introspection URL of GraphQL, or a WSDL of a SOAP API. Once you upload them into the active testing platform, they'll obviously be automatically added to the API inventory. And then, unsurprisingly, you'll be able to test your APIs. So you will be able to come in, press scan, and a scan would run. You could see a history of all the previous scans that ran. And if I click on a particular on a particular scan, I see all the tests that ran as part of that scan. And if I click on a particular test that failed, I'll see exactly why that's a problem. Like, what's the problem that the testing tool found on my APIs? Information of why this is a problematic incident, a link to the OWASP to kind of explain even more, and a full recording of what the testing tool ran against my APIs to cause it to break. right? Once a developer that works on that API has that, they can easily reproduce it. They can just go over the session, run the same payloads, and get the same result. This makes it very handy, keeps the remediation cycle short. They're getting the feedback as they're working on the API and not like 3 months later. So this is very handy. Most organizations are not using it by coming in and pressing scan, rather by integrating it to their CI/CD pipeline, which can be their Jenkins or the Azure DevOps or the GitLab or the GitHub and so on and so forth. The benefit of that is that you can configure, for example, for any minor version in my staging environment, please run the Noname active testing. For any release that is happening of a major version, run Noname active testing and block the release of any if anything was found. The feedback as part of the CI/CD integration is received on the actual CI/CD console. So you don't even have to open the Noname console to get the feedback. That makes it seamless for the developer to get feedback on the new things they release. And yeah, as I mentioned earlier, keeps the whole remediation cycle short, very beneficial. I would say that the tests that we include are not just API tests. A lot of them are. There's a long list of tests here, and a lot of these are like the OWASP top 10 API security issues. If I'm not mistaken, there are like 150, 160 tests that we include. But generally, we also include web tests and not just pure API tests. We also use some testing mechanisms that were already existing in the open source, but obviously we had to develop a lot of our own. So there's like, it covers you end to end, both from API perspective and web perspective. So we like to say like this is a full-blown DAST solution, if you will, that also includes covering your APIs. Yeah, anything you can do via the console, both of the active testing and the core platform, can be also done via an API. As we're an API security company, you can run the automatic tests, you can pull the API inventory, you can pull the issues, you can automate around that. Yeah, that's about all I have to say on the active testing piece. Are there any questions?
It sounds really good. Can you do, I don't know how to explain it, but can you do manual types of testing? Like, can you adjust the test cases if you're like, I'm really afraid of XYZ, or maybe even replicate? So like, let's say you had a security incident, or you think you had a security incident with one of your APIs. I'll let you
Yeah.
talk.
Yeah. So we do, we also offer, like, if you want to write your own tests, we offer an SDK on which you can use to write your own tests, upload them to the platform, and then they'll be used as part of our testing suite. I will also say that sometimes the authentication is the culprit. Like, organizations are using non-standard authentication, and then how can the tests be done? And so something that we enable them to do is to upload a script of their authentication, for example, a Postman script that our testing tool will leverage in order to authenticate in front of their APIs and then call their APIs. So we support custom authentication, but also custom tests that you can develop with our SDK and upload them into the platform. So yeah, good question. Yeah, something that's quite handy actually.
Yeah. If they, so like, let's say they share back with you a test case, is this a thing where, I mean, and maybe you don't want to answer this, but I feel like maybe eventually you'll have a bunch of customers that are really good at testing, and you might want to form like a community or something for them to meet each other so they could compete. I don't know. I bet there's a bunch of pen testers that are like, ooh, ah.
Yeah. No, that's a great point. Actually, as the testing part is usually something that is also developers like, actually, right? Because it's immediate feedback and not just like 3 months later. So yeah, there's definitely a lot of excitement around it, and they have no problem adding their own tests in and like extending the suite.
Very cool. Thank you.
Sure. So yeah, last thing I would mention is obviously the access control around the testing and the core platform is very granular. Like you can choose if a person can handle issues or just view them or view the inventory or only a slice of the inventory or anything like that. That's very important, especially for the large customers out there, is they need that granularity, especially in large organizations. But yeah, that's about it. I would say a challenge that we sometimes see that maybe it's important to tackle is that they come in and they have like a million traffic sources that are relevant to them because they have the Apogee and they also have the Kong and they also have the Mule and they also have Azure environment and so on and so forth. And sometimes it can be overwhelming as to how you cover that, cover all these use cases. So the answer is always you do it gradually. Like you pick a particular environment or a particular business unit and you just integrate with the relevant components for that. You finish or you wrap that up, and then you move on to other business units or other components. Through that gradual process, usually we get to full coverage quite fast. The last thing I would say is sometimes the API transactions are very sensitive and organizations are not feeling comfortable in sharing that outside their org, which is exactly why we don't just offer SaaS, but also a full on-prem deployment. On-prem, not in the sense that you need a physical box. It is a software. You just deploy it on a VM. But generally, like you host it locally in your cloud or in your data center, wherever you want, and the information never leaves the perimeter that it's on. So the API transactions that are sensitive never leave your perimeter. The analysis is done locally, the baselining, the posture management, everything is done locally, and you don't have to worry that someone will get access to that information.
That is very good to know. I know a lot of governmental organizations will really appreciate that. We have a question
Exactly.
in the chat. What is no-name sensor? What is that?
Oh, yeah, great question. So in some cases, okay, so let's take a particular scenario. Someone brought up a VM, connected it to the internet. How will Noname find that, right? It's not routed through anything. It sits on your data center. It's a particular server. You're curious, what is going on there? So this is more invasive of an integration, but we support that as well. Basically, you deploy the sensor locally on that particular instance. We would leverage eBPF, and we will be able to still get visibility into that bizarre host that you have out there and monitor if it has APIs, and if it has them, add them to the inventory, monitor them in an ongoing manner. So no-name sensor, probably a pretty word for you don't have any other way to cover it, so deploy this agent locally on that host, and then we'll be able to cover it. In most scenarios, we don't need that, but in some cases, organizations are having a few hosts that they have no idea what they're about, and they just use our sensor to deploy. They deploy our sensor on it, and then they get the visibility into that part of their org.
Cool. We have another question. So there's lots of companies that do API stuff. What are no-names functions that you feel really make them stick out from all the other ones? So you've already told us a lot of stuff, but like if you were going to highlight why we pick you,
Sure.
okay.
So let's go back to the model, right? So I'm not going to mention any names, but generally, if you look at this model and you think about a competitor or a vendor in that space, you will find that they fall under one of those pillars. Like in the majority of cases, it's going to be that middle pillar. They're going to do runtime protection and only that. That means that they're going to be able to alert you if you have a runtime incident going on, but they won't be able to proactively tell you about misconfigurations that you have in your environment because they don't analyze the configuration, because it's a very difficult thing to do. Or they do the configuration part, but they won't do the testing part. And then you have vendors that only do the testing, but they don't do the runtime. And so the problems with these approaches is two things. One is for large organizations, they always feel like whatever they would go after will not cover them completely, and they'll have to go shop to cover their estate. And two is that these components can feed into each other. As I mentioned earlier, for example, our testing tool benefits greatly from the fact we analyze APIs in real time. Because if we analyze the API in real time, we know how to call it during the testing phase to successfully actually test the API. And for good posture management, it's not enough to analyze just the configuration. You also need to analyze the traffic. Why? Because you want to understand that it's a sensitive API or sensitive internal purposed API that is open to the internet, and not just this VM is open to the internet, because there's a big distinction between the two. So every one of these pillar feeds into the other one, and they're kind of looking for this broad or complete solution, which is exactly where Noname is excellent on, is the fact that we do not just runtime transactions, not just configuration, but we do configuration, runtime transactions, and testing. We offer all three as part of a single platform. Everything is like feeding into each other. So that I think is the great benefit. And this is also what we like to say, this is also the right way to secure your APIs, and not just say, well, I'll find it in the runtime, or I trust myself to fix everything in the configuration. Like, you really need to do all three if you want to secure your estate.
Yeah, you want to look at it from all the angles, not just one. And in the chat, we're just like, oh, I don't want to have to buy two tools and then deploy two tools and then try to get the two tools to talk to each other.
Exactly. That's
What?
the main thing.
Okay. Does anyone else have any questions? Because, oh, Shai, sorry, I felt like you were wrapping up.
No, I'm done. I'm done. We're good.
Oh, yeah. And Sean adds on, or try to manage two vendors, because then you have to have two agreements, you have to talk to two teams. Yeah, not. Oh my gosh. This was great. Thank you, Shai. Are there any more questions? Because this is your chance, everyone. I feel like you answered all the questions as we went along. Oh, wait, I'm going to show myself. There I am. Hi.
I'll also show myself then.
That was really great. I thought that was great. That was super helpful. Thank you very much for coming on. Is there anything you want to add? Because I think everyone got their questions out already.
No. I will say definitely, like, if you haven't zoomed in your APIs yet, if you haven't taken action yet, I implore you to do so. Like, seriously, we hear about another breach every 3 weeks to a month. Take action, right? Take action to secure your APIs. They're a very lucrative and very easy attack vector. Like if I would be an attacker, that's the first place I would look at. It's just the easiest. It's right there. And a tiny gap or one API with a problem has a giant impact. Look at the Twitter example. It was one API. It leaked 220 million records. Like, that's because it's built to scale. That's what APIs are built for. And so one faulty API is big. Yeah, exactly. So yeah, that's what I would end with.
Is there any sort of trial version, or like people can call your company and ask like for a demo where it's more directed towards them?
Sure. So I'll say two things. One is, yes, we can offer demo. And two is that we offer workshops all the time where you can come in either virtually or physically. Even we have them physically sometimes around the US, where you can come in, play with the actual product. Like, we'll walk you through the API, the common API security incidents. We teach you, like, how do you approach them? What do they mean? Like, you get to play with our solution or our platform and generally mess around with APIs a bit. I would highly recommend that. Like, that's a pretty fun experience.
Would you be able to get you or Cassandra to send us when the next one is, so we can include it when we share this, so that if people are like, oh, I want to try it now, would that be
Sure.
okay?
Sure. I'll talk to Cassandra.
Awesome. Thank you so much, Shai. Oh, someone has another question. Oh, you said, is there an OWASP or a We Hack Purple member version? No, probably isn't.
That probably isn't. Yeah, that's true.
That's okay, though. That's okay. Thank you so much, Shai. This was wonderful. And it's so nice meeting you.
Nice to meet you too, Tanya. Thanks a lot.
Thank you to everyone who came. And thank you for everyone, if you're watching this later, for watching We Hack Purple streams. Bye, everyone.
Bye-bye.